So, can you guys hear me okay? Is mine loud enough? Should I project more? I know that air conditioner is coming. Can you hear? Okay, cool. Feel free to just raise your hand if I'm talking either too fast or not loud enough, because that tends to be two things I do. To talk too fast and not loud enough. All right, so thank you very much for coming to my presentation today on writing sustainable automated tests. This is going to be a little bit different than other automated test presentations you might have seen. Major difference is I'm actually not going to run any tests today. And I'm not going to show any code. This is going to be at a much higher level. I'm going to be talking about it more from like a conceptual level. I'm going to talk about, when exactly do you use a kernel test or a functional test or a unit test. I'm also going to talk about, this is going to be a workflow for like a developer's workflow. You're not going to be running any tests in pipelines or anything like that. We're really going to be focusing on like, okay, as a developer, I want to write my code, and I want to write my tests, and I want to use those to kind of reinforce each other into a rapid workflow for writing quality code. And so, first, let me introduce myself. My name is Josh. I'm a senior web architect at Pegasystems. I've been there for about 3 years, but I've been writing Drupal code for about 12 years, and I've been writing PHP code for about 20 years at this point. I've been running PHP for a long time. And what these slides here represent are really a distillation of learnings that have gone on for the last 2 years or so. Because at Pega, I'm spearheading an initiative to really start to incorporate automated tests into our day-to-day workflow as developers. And so all these slides here, what I'm talking about today is going to be from those learnings that have gone on over the last year. From mentoring other developers, as well as just some books that I've read, as well as practicing it on a day-to-day basis. So, just to make sure we're on the same page, what exactly do I mean by a sustainable test? This is a test basically where you just have to write it once, and it doesn't break. So you don't want to go and write some more feature code or make some refactoring and cleanup, and then all of a sudden your test breaks, right? And now you have to go in and you have to maintain your test and clean it up. That test doesn't offer you value. That test becomes a liability. What do we do with code that is not serving the purpose, like direct purpose of the business? We usually delete it, right? Because it's getting in our way. That's not what we want. If done correctly, automated tests can really offer a lot of value for the project. And that's what we want to achieve here today, this presentation. Okay, so before we get into that, let's take a little step back. Let's talk about software development in general. I'm a strong believer that software development is not a science, it's a craft. It's no different than if you're like a painter or you're a sculptor or you're a woodworker, right? You're using your hands and your mind to build something. And with software development, unfortunately with us, is that with the craft, it's really messy business. And we add in our code, we're trying to solve our problems, we put in a variable here, a function there, and over time, it gets pretty messy, right? Unlike painters or woodworkers, we don't have the luxury of having a studio where we can hide our mess over in the back room. Right? Painter might come to you, they have this beautiful canvas, you can hang it on your wall and you love it. Nobody has a beautiful, pristine studio where they came out of, right? It's the exact same thing with us. The problem is that we have to live with that mess and we have to deal with it, right? Because it will manifest, we have different words for it, like spaghetti code, software entropy, technical debt. That's one of the major challenges that we have to deal with as developers. And what are the risks of that? Why is that such a big problem to have that mess in our code? Other than just making it difficult to read. One of them is just the way that software is architected. Software depends on other software. It's this nature of interdependencies that creates an actual power law distribution. It's like a law of nature. It's the exact same thing that happens with avalanches or forest fires. So avalanches start with just a snowflake, right? And a forest fire just starts with a spark. It's the same idea with us. If you have a big collection of tests, you have a big test suite, you can have one bug, maybe a syntax error, and all of a sudden you can have lots of red in your application, right? So it's the exact same law in effect with software development. And that's the big risk that we have to deal with. So tests can help with that. And how can they help? is because they happen early enough in the feedback loop, we're able to catch that avalanche before it happens. And that's why it's such a great tool for us to be using in our day-to-day workflow. But where do you begin? How do you know what code is really worth your time to add tests for? And when I think about this, I really break it down into three things. I look at code, what code should I not test? And it's really three things. It's code that's not mine. Is it in Drupal core? Is it a contrib module, the vendor directory? I'm not going to bother adding a test for that because it's not my code. And in fact, hopefully that code already has test coverage for it. Second, I'm not going to add tests for is basic or trivial code. And this is one of the things you can kind of fall into if you're trying to achieve 100% code coverage. Like, oh yes, that's a requirement. We have to make sure all our code that we write is 100% covered. Otherwise, how are we going to catch everything? That's not realistic. And in fact, you're going to be creating a lot of code that is just not offering value for the project. So if anyone here thinks that getting 100% it's just not worth your time. It's too much extra work. And then finally, overcomplicated code. Now, I have a very strict definition of overcomplicated code. It means two things. One, you have a lot of conditions in it. Like, oh, if this, and then this, or if that, if not, but if not this. That's overcomplicated. But also, you have a lot of dependencies. Because now you have a lot of things that are coming in that you have to kind of deal with. And so, when you have code that's overly complicated, you're not going to want to add tests for that as well. Well, that's not 100% true. You might add a test to help you refactor it, to clean it up, and then you're going to reevaluate, okay, did I refactor it to make it more simple? Is it now trivial? I'm not going to add a test for it anymore. Or I might add a different kind of test. Maybe my functional test isn't appropriate anymore. So let's talk about those three different kinds of tests. Who here has heard of the unit, kernel, and functional tests in test suites? Okay, so yeah. In general, those are the three kinds of tests that you're going to be running. And it's really the same across different platforms. In PHP, we have PHP unit, but you also have a vhat, which is a functional test, and then you have JUnit, which is Java, which also has what they call integration tests, unit tests, and functional tests. So this is kind of a standard practice across different platforms. But when do you know when to use each one? It comes down to three factors. First, what's your priority? Do you want your test to capture as many bugs as possible? Or do you want your test to be fast? It's going to be either or. Second, you need to consider what your dependencies look like. And then finally, you got to take a look at the design of your code. How is it structured? This is also going to influence whether you write a unit, kernel, or a functional test. So let's talk a little bit more about priority. Because there are a lot of kind of overlapping concepts when you're looking at tests. And I really like the way this author here, Vladimir Porokov, who wrote this book, Unit Testing Principles, Practice, and Patterns. It's a fantastic resource. I'll have a slide at the end of this presentation. He broke it down into 4 pillars, which I find really helpful. And the ideal test is going to have all 4. You're going to have strong resistance to refactoring. That means when it's not a brittle test. When you make a change, it won't break. Protection from regressions. Make sure you actually catch those bugs as they come up. You don't want to let things slip through the cracks. Third is fast feedback. Make sure your test runs quickly. If your tests take 20, 30 minutes to run, you're simply not going to run it, right? And your test becomes a liability. And then finally, maintainability. Is it your test clear? Do you know what's going on in your code as you read down it? Do you know what's happening? But also, is it easy to run? Do you have to depend on Apache Solr or maybe some other third-party service that someone else would have to install in order to run your test? That's not a maintainable test. And 3 of these overlap. The resistance to refactoring, protection from regressions, and fast feedback. Ideally, your test would have all 3. But unfortunately, that's not achievable. So you're going to have to make some compromises as you're looking at your tests and you're designing them. One of them, though, is not negotiable. You need to make sure your code can change. Because as new requirements come in, as you gain new insights, maybe someone found a bug, you need to make sure you can change your code and it doesn't break your tests. So that always needs to be top of mind as you're thinking about your tests and how they're architected. So then you have to choose. Do I want to try to catch as many bugs as possible, but then my test is going to end up being pretty slow? Or do I want my test to be really fast, but I might have the potential of missing some bugs? So you have to kind of weigh those two factors and think about, in this case it's acceptable, and in this case it's not acceptable. All right, next, talk about dependencies. So these also influence the kind of tests you're going to write. Speaking very broadly, I like to group my dependencies into two. One, you can have your internal dependencies. These are basically just your classes talking to other classes, specifically code that's in your code base, most of the time that you wrote. Or you're using Drupal core, for example. The basic point is you're not talking to a third-party service. Second one is your external dependencies. These are your third-party services. Most of the time, I would say 99% of the time, the only external dependency that you'll interact with in Drupal is going to be the database. Thankfully for us, Drupal makes it really easy to interact with the database when we're running our unit tests or our kernel tests.
I'll have to disagree with that. We have a lot of external dependencies.
Oh, really? Do you do a lot of mocking?
A lot of API integration to other systems.
Yeah, let's. I want to chat more about that. Yeah, we can talk about that. Okay. So, the different tests are going to interact with the dependencies differently. If you have a unit test, you're going to do a lot of mocking. Who here is familiar with mocking the unit tests or heard of it? So, at a high level, with unit tests, you don't really have Drupal booted up. And so when Drupal boots up, it does bootstrapping, which loads a lot of the services that you might want to use in order to run your tests. When you have a unit test, you don't have any of that. So you're literally testing raw code. Like I'm looking at the class, I'm testing this function, and I'm not testing anything else. And so in order to test that, if you do rely on another service, you have to mock it, which essentially means I'm going to bootstrap it myself. I'm going to define the inputs and outputs of that code that I want to pass in to my class. And so when you have just like one or two dependencies, that's not a huge deal. But when you have 3 or 4 or more, doing all of that kind of assembly of your mocks can really get cumbersome. You can have lines of mocks just like going down the page, and that's just not maintainable, right? It's way too complicated with that. So you wouldn't want to mock anything more than 1 or 2 dependencies in the unit test. So that brings me to the next one, kernel tests. As your mocks are getting really big, now you can consider, well, kernel tests do bootstrap Drupal. They'll handle that all for me. So you can use a kernel test instead to run those tests. Kernel tests do support mocks. That might be useful, like in the case, maybe there is a third-party service that you want to test with, but you don't want to bootstrap that third-party service. You could mock it with a kernel test. Now, I've only done that a few times myself, but that's just the nature of the projects that I've been working on. Other projects, the tests really reflect the project, right? So you might be mocking it more with kernel tests. And then finally, you have functional tests. Here, you're literally testing your website in a browser. And so you have the full bootstrap of Drupal, but then you also have the browser, which I consider a dependency in this case. This would be a time where, like, I need to load this page and click a button, or I need to submit a form. You would do it with a functional test because you're literally interacting with the browser. And the focus on the API is less important in this case. In a conventional, not a Drupal project, in a conventional software project, tests are often going to be distributed like this. You're going to have a big base of small unit tests with just a couple of dependencies for each one. Then in the middle, you have a sizable amount of kernel tests, also called integration tests. And again, those have more dependencies than your unit tests. And then you're going to have your functional tests up top. And ideally, you just have a few. Your functional tests will be there to test like your happy path. Like for example, if you have a checkout system, it's just that single, okay, here's an item that I chose, then I'm going to go to add to my cart, then I'm going to go to checkout, and then I'm going, that single process, you might test with a functional test. Meanwhile, your unit and your kernel test, you can test all your edge cases. Like what happens if I get to the cart but I don't want to check it out? Or maybe the user logs in but their information isn't totally ready yet to be able to do it. You're going to test those with a unit in your kernel test. And the reason you do that is because functional tests are a lot slower than your unit and your kernel tests. So like I said, this is a conventional software project. Drupal looks like this. Drupal doesn't actually have very many unit tests going on. Surprisingly small amount. And then, decent size of kernel tests and a lot of functional tests. Surprisingly, a lot of functional tests. Anyone have any idea why this might be? Why does Drupal look like this? Well, a couple of reasons. One, heritage of the project. Drupal's pretty old. But two, Drupal uses the database a lot. Well, you can't really do much without a database in Drupal, right? I mean, that's where you store all your structural elements. Unit tests, you can't really work well with a database. So you're going to be doing a lot of kernel tests and a lot of functional tests. So as you're going along and you're writing your tests, and after some time has passed, and you realize, you know what, I haven't written any unit tests. I must be doing something wrong. Like if you're working in Drupal, you're doing it exactly right. Don't worry about it. And all the tests I've written, I'm probably up to almost 1,000 now. Maybe 12 unit tests. So just.
I'm glad you said that.
Just keep that in mind. Yeah.
You're making me feel better.
Yeah. I know, I was shocked too. The whole time I had this assumption in my mind, like, oh, it should be like this, I'm doing it wrong. But then I actually scanned the Drupal core code base, and I'm just like, nope, this is it.
Oh.
And I actually have numbers for it too, right here. Surprisingly, it's kind of close here. Okay, so we talked about the priority, fast versus slow. We talked about the dependencies. Let's talk a little bit about design. This is design for Drupal after all. So spend a little bit of time talking about it. So when I think about design with my code, I really group it into two categories. I group it into infrastructure code and domain code. Now, when I say infrastructure, I'm really talking about pretty much the code that just deals with the concerns of the software itself. These are a lot of things that are shared across different applications, like your caching layer, authentication, user accounts, routing, rendering, all that kind of stuff. This doesn't exist outside software, and it's often shared for different kinds of software, right? That's your infrastructure code. Also, infrastructure code tends to take up the vast majority of your code base. Right? Then there's domain code. Anyone here familiar with domain-driven design by Eric Evans? So he pioneered this really approach and a way of thinking about software design where you orient your code around your business. You do a hard separation between infrastructure and your domain. And so your code that you write is going to represent concepts that exist outside of code. So for example, let's say you have a bookstore, right? With a bookstore, you have book listings, you might have payroll, you might have book prices. All these kind of concepts can live outside software. And you can just have a brick and mortar store and it has all these concepts. And then you can represent them in code. And so that's what he advocates. Let's take these concepts that exist on their own outside of software, we'll bring them in and we're going to write our code oriented around that. And so, long story short, is code that is directly concerned with the needs of the business. What also happens with structuring your code this way is that it takes up a much smaller portion of your code base. Just to give you an example, I'm working on a contrib module called access policy, which deals with restricting access to content for different kinds of users in different departments. And last time I scanned that to see, okay, well, how much of my code that I actually write is actually doing that? And how much is it infrastructure? And it was like less than 1% of that code was actually solving my company's business needs. Don't tell my company that, but that's how much the code was actually dealing with their concerns. The rest was just putting it all together into a software package. So that
You mean
kind of makes
by
sense.
that, like,
So, for
adding
example,
it to the menu system, like so it has an admin page. Is that what you mean by infrastructure? In the Drupal
yeah,
process?
infrastructure is like you have your routing service, which responds to a request, and you have a request service. Like that's infrastructure code,
Okay.
right? And in my access policy example, I create all this stuff for like handling 404s and 403s and stuff like that. But the actual code is like, okay, does this user have this member? I'm checking, does he have this member type? Yes or no?
Okay.
That code, that's domain code. And that only took less than 1%.
I can see that.
Yep. That's a good question. Actually, one question here. Where does Drupal like to put its domain concepts? Where does it like to nudge you?
Configuration.
Yeah, exactly. I mean, I'll put it on the slide. Yeah, Drupal likes to put all its domain concepts into configuration.
Yeah.
So that's why you get content types, that's why you get fields. If you're familiar with Drupal distributions, like Pigno, and you can name another one, my brain.
Social.
Open Social, yep. All of these are domain concepts. And anyone here familiar with Robert Martin? So he's an author. One thing he likes to talk about is screaming architecture. And so like with the distribution, what he means by that is like, when you look at this, I know this is for authoring, or I know this is for a learning platform, right? So you tailored your application to solve a business purpose. And that's what a distribution is for. And Drupal loves putting it all in configuration. So you'll see too, if you look at it from this point of view, you'll notice that when you're writing your code, you're constantly being nudged to throw stuff in configuration somehow. And that's because Drupal just wants you to put everything in. So that's why the database is used so much. Okay. Why do we need tests for both? Why do we test for infrastructure code? We need to make sure people can actually see the page, right? Or that it's loading the right page. You don't want to load the wrong page. If you can't load the website, then it's just not, it's not working. Why do you need tests for your domain code? You need to make sure it's satisfying business requirements. People need to be able to buy that book. If your website's working, but you're not satisfying the business requirements, your website is basically a yacht, just sitting up there in a browser. It might look beautiful, it might work great, but it's not generating any revenue for the business, and it's not or satisfying the requirements of the business. So a question for you. If you want to really optimize the test that you're going to write, which one should you write a test for? You want to get the highest return on value for your test, the least amount of effort. Should you be writing a test for infrastructure or for domain code? Domain code, right?
Yeah.
At the end of the day, at the end of the day, that's the most important. You need to make sure that the business requirements are being met. So if you want to, if you leave here today and you want to write your first test and you're trying to find some code, first find some code that's not yours, and then find some code that's directly concerned with the needs of the business, and then add some code coverage for that. Also talking about design, these tests, unit, kernel, and functional tests, they don't work in isolation. You're usually going to use them together in some way. And this is where the kind of strategy and design of your whole test suite comes into play. So looking at this example, this is just using a conventional software layering architecture. You might, with a book listing, for example, this deals directly with domain code. So I might write a unit test or a kernel test to cover that kind of nugget of domain code. Again, this is a smaller portion of your code base, so hopefully there won't be a ton of code that you need to cover. And here you can add in all your edge cases and your corner cases as you're adding tests for your book listing. And then on top of that, you can add some functional tests that will cover the view controller or any of the infrastructure code that might be on top of it. This also is kind of a good representation of why one test might be able to catch more bugs than another. Because my unit and kernel test down here really only know about the book listing. They're not going to catch any bugs that might happen in the render service or the view controller. So that's why you need a functional test in order to catch those bugs as well. Okay. All right, so this is all great from a conceptual point of view, but what does writing automated tests look like in practice? So there are generally two approaches to writing tests. You can write your tests after you've done your initial feature development. It's a very common approach, perfectly acceptable. And then there's also the other approach called test-driven development, or writing your tests before you write your feature code. Who's here familiar with test-driven development? Anyone practice it before? You tried to practice it?
Badly.
There's no badly. All right, so I'm just going, for those who don't know, I'm just going to go over it briefly. So test-driven development has this kind of famous mantra that it likes to follow, and it's red, green, and refactor. Red means I'm going to write a test to make sure it fits. And with test-driven development, if you don't have any feature code, it's going to fail every time. So that's perfect. So for example, let's say you want to load a page and click a button, but the page and the button doesn't exist. You can still write your test. It's just when you go to that page that you're expecting, you're getting a 404. That's perfectly fine. A broken test, you've gotten to red. Congratulations, you've written your first test. Now, you've done that. Next you're going to get to green. From here, what you're going to do is you're going to create your controller. You're going to write your code. And this is the fun part too, because here, you're at liberty to write some of the worst code you've ever written in your life. Like, break all the best practices you want, and then just get to green, meaning after you write your test, write your code and get it to pass. It really doesn't matter how you get there, just get there. And then once you got there, your test is running well, even though the code might be terrible, you commit it. Then you go to the last part, and you refactor it. Now you start to exercise a different part of your brain. You no longer need to solve the problem. You figured out the problem. You got all the insights that you need. Then you go ahead and you start cleaning up your code. All the while, you make a code change, you run your test. Make sure it always stays green. And then you make a change again, run your test. If it gets to red, go back, undo it, make changes to your code again, and make sure it always stays green. The nice thing about this is that as long as your test stays green, you can go as far or short as you want when you refactor it. So it gives you a lot of runway with your code of how you want to get it. So you could, you push it up and you say, hey, the reviewer is like, this is not good, why are you doing this? And it's like, well, the test runs, we can always come back to it, especially in a time crunch, for example, like a hotfix or something. So that's generally the approach for test-driven development. The thing I kind of like, this is kind of akin to, like full disclosure, I'm actually an art major. I got my degree in studio art. This is like sketching. After you've added in your tests, you're literally you're playing, you're figuring out ideas, you're not worried too much about the technical stuff, and until you get to green. So it's very much like sketching. It really gets to open those ideas, and it removes a lot of those constraints that you might run into. That's why I'm a big advocate for test-driven development. All right, so that's all great. Now we all want to do tests. We're going to leave here and be super motivated and write the best code we've ever written. Well, it does take extra time. There's really no way around it. In this study that they did at Microsoft, it took about 15 to 30% more time to write your tests. So you're going to have to factor that in as you're considering writing your feature code. But even though it took a little longer, they did see improved code quality. In the same study, they saw those when they did tests afterwards, there was about a 29% decrease in defects. And then when they did TDD, there was about up to 91% decrease in defects. And actually I want to stress too, it's not either or, like test-driven development or conventional test development. Really, in reality, you're going to be doing both. Sometimes you're going to find some code, this is a good candidate for writing a test. Or you're going to find this is a new feature. Hey, this is a great time for me to write my test first. So it really depends on the situation. So I don't like to be overly dogmatic about, no, it has to be TDD. It's a great approach, but it's rarely ever going to be like that in the real world. Okay, so we just covered a lot of material in about half an hour. Hopefully everyone's able to keep up, because it is a lot. So I'm just going to do a quick recap. So again, trying to identify code which might be worthy of tests. I tend to go through this thought process. First is the code mine. If it's not, I'm not going to bother writing a test. I move on. If it is mine, is it trivial? Is it a getter or a setter? If it's trivial, it's not really worth my time to add a test. I'm going to move on. Is the code overcomplicated? Again, overcomplicated codes means there are a lot of conditionals or there are a lot of dependencies or both. If it's overcomplicated, I'm going to, maybe I'll add a functional test to support me while I'm refactoring it, but maybe not. Maybe I'll just go through and I'll clean up the code, get it to a point where I feel happier with it, then I'll start adding my tests and to clean it up. I might even refactor so much that I refactor the overly complicated right into trivial. And then no test at all, and this is like the best thing ever, right? So after that, I'm going to take a look. All right, I've refactored it. I need to consider my dependencies. If it's one or two, I'll consider a unit test. Unless there's a database involved, like a Drupal, then I'm probably going to write a kernel test. Or if there's 3 or 4 or more, I'm probably going to write a kernel test. Unless there's a browser, I need to click a button or something, then I'm going to write a functional test. But I'll also keep in mind, okay, I've decided to write a functional test. I know I'm going to catch more bugs, but I also know it's going to be slower. So I need to be aware of that and need to consider that as I'm designing my test. Also, if I'm writing a unit test, I know that's going to be a lot faster, but I won't necessarily catch as many things as a functional test. So you're always going to be doing a mix between, in Drupal in particular, kernel tests and functional tests. And I'll say too, when you decide to do a functional test, just make sure and reevaluate it. It's like, okay, do I actually really need to test this piece of functionality? Is the browser really important in this case? Because you know, the more you add, the slower it's going to be. And kind of going on that vein, you're rarely, if ever, going to have tests in isolation. You're usually going to do as part of a kind of a broader strategy of test coverage, using a mix of slow tests that capture a lot of edge cases, fast tests that capture a lot of edge cases, and then a slower test that goes through a happy path that offers bigger coverage in your code. So we're coming up to the last slide here. I mentioned some of this was inspired by this book right here, Unit Testing Principles, Practices, and Patterns. It's a fantastic resource if you want to learn more. Some of this material was covered in there, but he also goes into way more into depth with dependencies. And it's a great starting off point. I highly recommend this. So, here, I'll leave that slide up if you guys want to see it. So, the last one's just a thank you, so I can say thank you right here. So, thank you very much, and we actually have a lot of time for questions, so happy to open it up right now. Yes?
This is a Drupal-specific question.
Mm-hmm.
When you're testing something that you need to mock, there are different modules or plugins or things people have written. Do you have a particular one that you like?
So the question is, when you need to do mocking in unit tests, there are other tools out there that might help you to make it easier to run your unit tests. It's not something I've used myself. I've always just kind of mocked it myself. And again, with Drupal, I've mostly run kernel tests and functional tests in it. Occasionally, like recently, I did have to mock a service that I actually had built that was talking with a third-party service. And yeah, so long story short, no, I haven't really used any tools for mocking myself. You do remind me though, there is a great tool in Drupal core called Prophecy. I don't know if you've used that one.
I have been exposed to it, but I can't say I really understood it.
Ah, gotcha.
So I used it, but
Definitely worth your time over the old testing framework.
so
Prophecy, yeah. Yep, it's a fantastic one, actually. Thank you for reminding me about that. I completely forgot. Yes?
You got me thinking, as I'm thinking through all of these, the unit testing, kernel testing, functional testing, as a developer, oftentimes, like leadership, stakeholders, they don't understand testing necessarily, so
Yeah.
they don't carve out time and budget in order to allow for it. And even though I kind of like the test-driven development because it kind of forces you to scope the things that you're going to be building
Exactly, yeah.
out, I'm kind of thinking it also helps you make the case for testing because it's kind of baked in.
Yep.
I think my question would be, is there a way to kind of drive home the point to stakeholders for buy-in and purse strings and timeframes to kind of allow you that grace?
That's a great question. So, just to repeat from the microphone. So the question is, how is there a way to kind of get buy-in from other stakeholders with automated testing? Because it does take more time to implement. Yeah, I would say like with Pega, for example, I've been spearheading an initiative to really incorporate it into our testing. And I got some allies to work with me. So like I had a few people who all became advocates for automated testing. So we came to our manager and say, hey, we really think like this is useful. Let's use it for this particular task that we want to do. You know, and particularly if it's like a complicated task that you know they're going to be iterating on over time. We found that was really helpful. So like, you know, this is just the first feature we're adding as part of a bigger feature. Let's add some tests for this because it's really important. That's the other point too. If it's critical to the business, I think you'll probably get more buy-in as well. Like, our business can't function without this feature, and there's a lot of risk involved. Let's add tests. I think that's a good way to convince them as well.
I like the allies.
Yep.
Yeah, because when they hear the message from multiple people, it starts to drive it home.
Exactly.
Thanks.
So we do behavior-driven design, where it's, you know, business understandable, you know,
Yes. Yeah.
Gherkin, you know, given this precondition, run this, run this. So we have all of our functional tests automated because those make sense to
Yes.
the business. And the reason I came here is because I've been feeling that we were doing it wrong, right? That we should be doing more unit tests, more kernel tests, because we're going to miss those edge cases because they run so slow. You know,
Yeah.
that you can only do happy tests, and so we miss edge cases right now. But it's easier to sell to the people who are setting the deadlines
Right.
because
yeah.
they understand the functional tests. They don't understand
Yeah.
the other kinds of tests. So I don't know what my question is here. I guess it's kind of, have you run into that?
I'm with you though. I know what you're getting at.
Yeah.
Yeah, like how do you kind of explain, what's another way to explain like the benefit of using unit and kernel tests? And just to repeat, the question was like, we're using BHAT tests in our project and that's easy to kind of justify to business stakeholders. How can we justify things like unit tests and kernel tests? One way I kind of explain it when I'm talking to stakeholders is that with unit tests and kernel tests, we're testing the windshield wipers, we're testing the wheels and the tires and the engine of our car. All these different components, we're making sure they work. And then we use our functional test to drive down the road and make the delivery of whatever we need to deliver, right? And so I kind of like to do it like that, and that kind of helps them, oh, I get it. You know, because like, if the windshield wipers don't work, you're not going to go driving in the rain, right? So you're going to run into problems.
Kind of flip side of that though is developers hate writing unit tests. They hate the mocking part. It's hard to do. It's
Yes.
hard to make it so the test is really a good test.
Yes,
Because you're
right.
not you're mocking it. It's not real. Right? So I guess that's the flip side. If you have to, how do you motivate your developers to see the benefit to them?
Write kernel tests.
Yeah. That's,
At least get them started on kernel tests.
yeah, that's true.
Because
Yeah.
the mental shift is difficult to kind of get there. Yeah, it's definitely like I said, like from the very beginning of the slide, like software's crap, right? You got to think of it like that. And so it's a whole paradigm shift when writing tests and code. It's covered by tests.
That ties in with the concept of allies, is that if you you don't have your developers on board with writing these
Yes.
tests, then there's no way you're going to have enough allies to convince the business.
Exactly. Yeah. Yeah, just for myself, just anecdotally, what I did is I identified someone on each other project. I'm the tech lead on Pega Academy, which is our training platform, but there's other tech leads on Community and Pega.com. And so I'm like, oh, I'm going to talk to Anthony. I'm going to talk to Jerome, you know, and I'm going to like, hey guys, check this out. I'm going to got this presentation ready for you. And then I kind of get them on board, and then we set up dev huddles. And so now everyone is kind of drank the Kool-Aid, as it were. But they're all on board with automated testing, and so that just makes my job a lot easier. I just did early advocate for automated testing. So, and actually, none of these ideas are new. I'm just standing on the shoulder of giants here. This was spearheaded by Kent Beck, actually. I have a little bonus slide. He loved test-driven development. He was a big advocate, and he's very dogmatic, too, about it. But if you want to learn more, the amount of material in this is actually surprisingly deep. And all the kind of big thinkers, Kent Beck, Martin Fowler, Robert Martin, they're all buddies, and they all talk about test-driven development, software development the same way. So I recommend any of those guys if you're interested in learning more.
Who's the Ruby guy?
Kent Beck.
Yeah. I don't have it, so.
A lot of